For this example, we're given two different functions. The first function, f of x, is just x squared plus 4. And then the second function, g of x, is x plus 3. So for part A, we're asked to find f of 2. So that's just notation form for saying when x is equal to 2, or if you plug in 2 for x, what's your output? So because it's f of 2, we're looking at this pink function here. So if I plug in 2 for x, I would have 2 squared plus 4. So that's 4 plus 4, which is equal to 8. You could also write your answer as an ordered pair. When I plug in 2 for x, my output was 8. So for part B, I have g of 3. So again, this is notation for saying if you plug in 3 for x, what's your output? And because it's g of 3, we're using this function. So if I plug in 3 for x, I would have 3 plus 3, which is equal to 6. So again, I could write my answer as an ordered pair. When I plugged in 3 for x, my output was 6. For part C, this is the composition of functions. So if I read this, I would say f of g of x. Looks a little scary when you first look at it. So let's change the parentheses. Inside the parentheses, g of x. Let's think of what that is. So g of x, that entire function needs to go inside here. So instead of writing g of x, I'm going to write x plus 3 because they're exactly the same thing. So now it looks a little easier. So f of x plus 3. So again, what is that asking? That is asking you to plug in x plus 3 in for x, right? Into the function called f of x. So I'm taking this function, and wherever there's an x right here, I am plugging in x plus 3 there. So I would have x plus 3 squared plus 4. So to expand this, x plus 3 squared is x plus 3 times x plus 3. And then eventually we'll add 4 to our answer. So I have to distribute here. Starting with the leftmost term, distribute the x to both terms in the second parentheses. X times x is x squared. X times 3 is 3x. Next, we distribute the 3 to both terms. So 3 times x is 3x, and 3 times 3 is 9. And then we have to add 4 to that polynomial. So if I look at some terms I can combine the x's here, and then I can combine my constants. So in standard form, I would have x squared plus 6x's plus 13. So that is the composition there. So lastly, part D, f of g of 4. So again, I'm going to look at what's inside the parentheses here. G of 4. So I need to figure out what g of 4 is, and then I can rewrite this original operation with whatever g of 4 is. So finding g of 4 is saying when I plug in 4 for x, what do I get as my output? So here's the function g of x. If I plug in 4 for x, that would be 4 plus 3, which is 7. So I could replace this with the 7. So finally, I need to find f of 7. So all that's asking you is to plug in 7 for x, right? So into this function here, if I plug in 7 for x, I would have 7 squared plus 4. 7 squared is 49. 49 plus 4 more would be 53.